Welcome back, ninjas. You've learned loops how to automate tasks over data structures. Today's lesson is a big one. Functions, the reusable building blocks you'll use to structure, simplify, and modularize your code. Let's hop into the code and run editor and begin. In JavaScript, a function is a block of code you can name and call whenever needed. Think of it like a mini program that performs a specific task and can accept input and produce output. Functions in JavaScript are first-class objects. You can pass them as arguments, assign them to variables, or return them from other functions. Under the hood, each function is an instance of the built-in function type. Functions are the basic reusable blocks of code. Let's explore the different ways you can define and call them, and what each pattern is useful for. Function greetSimple. Println, hello from greetSimple. greetSimple. This function takes no inputs and returns nothing. It simply performs a side effect, printing a message. We call it by name followed by parentheses, greetSimple. Use this pattern for small tasks like showing notifications or updating UI. Function getRandomInteger. Return math.floor, math.random, *100. Constant equals getRandomInteger. Print, random, plus n. Here the function computes a value and returns it. To use that result you must capture it in a variable or pass it directly to another call. Returning values is how functions produce data rather than just causing side effects. Function greet, name. Return hello, plus name plus exclamation point. Print, greet, ninja. This is the common case. The function accepts input, name, and returns a value. We call it with greet, ninja. The return string can be printed or used elsewhere. Function announce winner, player. Println, winner, plus player. Announce winner, Ava. This function accepts input and performs an action such as printing, updating the DOM, or sending a network request, but it returns nothing. This is useful when you want the function to do work rather than compute a value. Function divide, A, B. If b equals 0, return error, division by 0. Return a/b. Println, divide, 10, 2. Print, divide, 5, 0. You can return early from a function to handle edge cases. This pattern keeps your logic clean and avoids nested ifs. Function multiply, a, b equals 1. Return a*b. Println, multiply, 5. Println, multiply, 5, 3. Print, multiply, 5, 3, 2. JavaScript lets you specify default parameter values. If the caller supplies fewer arguments, the defaults kick in. If the caller supplies more, extra arguments are ignored unless you explicitly capture them. Function sumall, numbers. Return numbers.reduce, acc, n, arrow function acc plus n, 0. Print, sumall, 1, 2, 3, 4. Use the REST parameter syntax, numbers to accept any number of arguments as an array. Great for utilities like sumall or formatting functions. Function declaration, hoisted, say hi, function say hi, println, hi from declaration. Function expression, not hoisted, try, say hello. Catch, error. Println, error, error.message. Const say hello equals function. Println, hi from expression. Say hello. Function declarations are hoisted, meaning the engine makes them available before the code runs, so you can call them earlier in the file. Function expressions, like assigning a function to a variable, are not hoisted the same way. Calling them before the assignment causes an error. This matters when organizing code. Const add equals, x, y, arrow function x plus y. Print, add, 4, 6. Arrow functions are concise and great for short callbacks. Note, arrow functions don't have their own this binding that's important in object or class code, and we'll explore it later. Function do nothing. No return. Print, do nothing. If you don't explicitly return anything, JavaScript returns undefined. So remember, if you expect a value from a function, make sure it actually returns one. pure. Function add pure, A, B. Return A plus B. Impure. Let total equals 0. Function add impure, X. Total plus equals X. Printline, total is now plus total. Printline, add pure, 2, 3. Add impure, 10. Pure functions always return the same output for the same input and have no side effects, easier to test and reason about. Functions that change outside state, like add impure, cause side effects. Both have their place, prefer purity where possible, but you'll need side effects to interact with users or the network. If your function call doesn't work, check the function name and spelling. Confirm you're passing the right number and type of arguments. If you get undefined, you probably forgot return. If you get a reference error when calling, verify hoisting versus expression position. Const square equals function, n. Return n multiplication n. Print, square, 3. Here we assigned a function expression to a constant named square. These functions can be anonymous or named. Function expressions are not hoisted, meaning you must define them before calling. Const add equals, A, B, arrow function A plus B. Print, add, 5, 7. This is an arrow function, a shorter syntax introduced in ES6. It implicitly returns the expression when using concise bodies, and does not have its own this, arguments, or constructor behavior. Const add default equals, A equals 1, B equals 2, arrow function. Return A plus B. Print, add default, 5. Here we also used default parameters, so if you call the function with fewer arguments, the defaults fill in. This makes your functions more robust. Function greet, name. If, type off name equals string. Return hello, $name. Else. Return hello, undefined. Print, greet. Print, greet, dev, 42. You can call functions with fewer or more arguments than parameters. They guide the call but don't change the call itself. In traditional, non-arrow, functions, you can access the argument's pseudo-array inside the function to examine past values. But arrow functions don't have this feature, and it's often replaced by REST parameters. Now we'll talk about scope, which variables a piece of code can see and change. Scope is one of the most important concepts for avoiding bugs and writing predictable programs. Let's explore the common types: global scope, function scope, and block scope. Function outer. Const secret equals JavaScript ninjas. Function inner. Print, secret. Inner. Outer. Here secret is declared inside outer. It's local to that function code. Outside outer cannot access it. When inner runs, it can read secret because inner is defined inside outer. That's lexical scope. Functions remember the variables where they were defined. If true, let block var equals I'm inside the block. Const block const equals 42. Printline, block var, block const. Let and const are block scoped. That means inside only. If you declare a variable inside an if or a for block, you cannot access it outside. This prevents accidental leaks of temporary variables. Function test var, if true. Var x equals 10. Print, x, test var. Var is function scoped, not block scoped. If you use var inside a block, it's still visible throughout the function. That can lead to subtle bugs. Another reason to prefer let/const today. Print, type off hoisted var. Var hoisted var equals hello. Print, type off hoisted let, reference error, if uncommented. Let hoisted let equals hi. Declarations are hoisted moved conceptually to the top of their scope, but var and let/const behave differently. Var is hoisted and initialized to undefined, so type-off hoisted var returns undefined before the assignment. Let and const are hoisted too but are not usable until execution reaches their line. This is the temporal dead zone and will throw a reference error if you try to access them too early. Const also requires an immediate value at declaration. Let value equals outer, function show. Let value equals inner. Printline, value, show, print, value. If you declare a variable with the same name inside a more nested scope, it shadows the outer variable. The inner one is used inside the function, the outer one remains unchanged outside. This is normal and useful, but naming clearly helps avoid confusion. Function forgotten var. Accidental equals oops. Forgotten var. Print, accidental. If you forget to declare a variable and just assign to a bare name, JavaScript, in non-strict mode, will create a common source of bugs. Avoid this by always using let or const, and consider using useStrict to catch these mistakes early. Let counter equals 0. Function increment, counter plus equals 1. Increment, increment. Print, counter. Inner functions can modify outer variables. This is powerful but can make reasoning harder if many functions change shared state. Prefer returning values or using local copies unless shared state is really intended. Function makeGreeter, name, return function, print, hello, plus name plus exclamation point. Const greetNinja equals makeGreeter, ninja, greet ninja. This pattern shows a closure. The returned inner function remembers the name variable even after makeGreeter has finished running. Closures let functions carry private state and are the foundation for many advanced patterns. We'll cover closures deeply in a later lesson. For now, know that nested functions remember the environment where they were created. Prefer const by default, use let when reassignment is needed, avoid var. Keep variables as local as possible. Narrower scope means fewer surprises. Name variables clearly to reduce shadowing confusion. Avoid accidental globals, enable useStrict in files or modules. Use functions that return values, pure functions, where possible, minimize shared mutable state. Using what we have learned so far, let's see a real-world example of how function can be used to implement calculation functions. Const sum equals, arr, arrow function. Let total equals 0. 4, let number of arr. Total plus equals number. Return total. Print, sum, 1, 2, 3, 4. Function multiply, a, b equals 1. Return a asterisk b. Print, multiply, 4, 5. These functions encapsulate tasks calculating a sum, multiplying numbers with flexibility in parameters and clean logic. You call them with different inputs and reuse them anywhere. That was your first deep look into functions. Declarations versus expressions. Arrow syntax and default parameters. Handling of arguments and type-off. Scope rules and data privacy. Now head over to javascriptninjas.com, where you'll find 5 practice problems tied to this lesson. Each lets you write the function, run it with test inputs, and check your solution, or reveal it if stuck. See you next lesson OOP.